So we want to look at paths. So this idea of a path, and so all you're trying to do is, in essence, create something. If you remember, and I'm sure everybody's done this no matter where they're from, connect the dots picture. So for instance, you could have dots and they would be in a particular order. And I'm not going to draw anything in particular here, but you would then connect these dots in this way to get your picture. So there was a curve, but it mattered what order you connected your dots. So for instance, that picture is very different than if I erase those, and instead of connecting them in the correct order, if I connected them in some other order, I would get a very different picture, if I did that. So order here matters, and so to make the dots we need X and Y's, but to get the order you need something to put that order in, and we call that a parameter. So these paths are parameterized, and so you might have just something like this where you say, well, your X coordinate is equal to maybe we'll go with something like t squared, and your Y coordinate we'll make that maybe 2t. And now, what does that make? Well, you do that just like you would plot any plot. You need your X's and Y's, but what you want to do is make them from the T's. And so instead of what we would typically call a T chart with X's and Y's, we're going to make an H chart here. Now again, you can use T's from anywhere, but you want to put them in order. And so we'll go 0, 1, 2, 3, 4, like that. And so now this makes a 0 and a 0, and then 1 squared is 1. Oh, I think I have to put you on pause here. I need to hit escape and pause. Okay, so yeah, so if t is 1, then y is 2. If t is 2, then x is 4, because that's 2 squared, and then 4 for y. We've got 9 and 6, 16 and 8. And so, if I came over here and started drawing this, I would have 0, 0 first, then 1, 2. So at this point, I just look at this and do them in order. And so, let's see, 1, 2, and then up here at 4, 4, and then 9, 6, and this looks something like a square root function. And, so there's my path, something like that. Okay, now I can do this on Desmos and very easily. And so what I'll do is go over here to Desmos and let me first do it as points just to kind of prove I can, I guess. So the way I would do this as points here would be I'll insert a table. Whoops, that's not what I wanted. I'll insert a table. And so, you know, I've got an x1, a y1, and if I put another one over here, it'll probably be a z1. But so let me just, as an x1, I'll put a 0, 1, 2, 4, up to 4, just like I had before. And then here, what I want to do is I'm going to rename this as big X, and here I'm going to say that big X is equal to x squared. Okay. Oh, well, I'm not sure why. Oh, I have big X, and then I'm going to say of x1. Oh, well, I'm not sure why that's giving me a problem. Well, let me try instead. Oh, big X of x. There we go. Okay. So there, right now it's plotting these pairs of points here. Okay. But now I'm going to add one here. I'm going to do a big Y of x1. Of course, it doesn't know what big Y is yet. And so big Y of x is equal to 2x. And what it did was it plotted it that way. Okay, so it's assuming those are the x's and it wants to do a bunch of different y's. So I'm going to turn those off so we don't see them. I'm going to turn these off so we don't see it. But now I'm going to plot the ordered pairs of well, let's see. Let's try big X, comma, big Y. Well, okay, so this may not work the way I was hoping it would. Let's try, oh, here we go. Let me do this. Yeah, let's do it of a list here. So here's a list. So this is all much more complicated than we need to do. So L equals, and I'm going to make a list of 0, 1, 2, 3, 4. And there we see my points. Okay, so I was hoping to do it straight from this list, these lists here. And I guess I just wasn't able to. I don't know if I could do some x2 here. X2 equals. Nah, it doesn't like that at all. Yeah. So anyway, I made my list in here of the values. And notice, you know, I used T before, but I've stayed away from T on this because T does have a very special meaning in Desmos, and it means exactly what we used it for. It's a parameter. So I didn't want to put it in here or something like that and cause this to get confused. But you see, this just does it, right? Is that there's the squaring function, there's the 2 times function. I put this list in and it just plots those points just like we did. And those are these points, and I can see it in that table. Okay. Now, like I say, way more complicated than we have to get to do all this. I can get rid of these things and just start with, okay, I want to plot those 2 functions as parameterized by t. Well, I just do it as a point and I use t. So I'm going to use t squared, comma, 2t. And you see it starts doing it and tells me, well, it's letting t go from 0 to 1. And I can, let it go to 4, in which case it now, of course it's filling in everything. It's not just doing it 4 or 5 points, it's doing lots and lots of points. And so that is a parameterized path, and that's all it is. I mean, there's nothing more to it than that. Now, there are some, if you look at your, so let me add a note. If you go back and you look at chapter 10 of your calculus text, it will have a bunch of paths in there, some very pretty ones, some very interesting ones. But if you just give me a path, if you tell me what your path is, then I can put it here. Now, one of the paths that we're using in this class, they mention a lot, is they say e to the I theta t. I have no idea what will happen here, or let's see, e to the I, well, they say e to the I theta, or e to the I t, I guess. So e, it doesn't know what I is. See, it says add a slider. So oops, t, see, so it has no idea what that means. However, remember that this is just e to the it is cosine t plus I sine t. Okay, well, see, it's still totally confused if I write it that way. But remember, this is the x, or the real part, and the sine t is the y, or the imaginary part. Yeah, that's what we do, is we put it in that way as the real and imaginary part. And this knows exactly what we're saying. And remember, e to the I theta is just, or e to the it, just has magnitude 1, and yeah, you see this is what this does. And if I go to 2 pi, I get the whole circle. And so, this is just cosine t plus I sine t. But we use that a lot in this course because, well, it's e to the it, or e to the I theta, and it makes that nice circle of those complex numbers. So it's the unit circle. And then if I want to make it bigger, I can just multiply by something, and I think I can even just multiply out here if I wanted to. Yeah. So I could either make it 2 cosine, 2 sine, or just multiply out in the top out there. And I can also, sorry, yawning. I can also add a center. So suppose I want to put the center here at 6, 4. I can say like plus 6, and oh, I've got the 2 on there, so it's multiplying that by 2. So that I would, if I would need to put the 2 on the cosine and the sine like that, and then plus 4 here, and I can move the center that way. Okay, because what I've done is I've just changed the x value by 6 for every x value. Oh, well, yeah, sure. So that moves the center over by 6 to the right, and I've moved the y up by 4, and so I get that. And so that's a circle of any size and any center. I can always do that. Now you can do fancier things. If all of a sudden I did a minus and a minus, oh, well, I need to put those in parentheses. Now it doesn't look any different. However, remember that went clockwise from right here. Now if I look at that, you see it's going counterclockwise now because the angles are negative. So I can change the orientation. If I change this to the sine and that to the cosine, I change the starting point. So there are things you can do to get fancier with it, but generally speaking, we're pretty happy if we just do that standard circle and do it this way, and then whatever I need it to go to, like 2 pi. Okay, so that's a circle. This is just any general. You give me a formula for the real part and the imaginary part, I can just plug it in like this and I'll get a picture. And then the other thing we do is a straight line between a couple of points. And for a straight line between 2 points, so I'll give you 2 points here. So I'll say point A is equal to maybe 1, 2. So I've got that point there. I'll give a point B. Maybe make that one at 4, 6. Okay. Now the way I'll do a straight line between them, so this very often I'll want to do a straight line between 2 points. So here's point A, point B. All I need to do is take A times 1 minus t, and then plus b times t, and there's my straight line. And now notice if I make that like 0.2, you see I'm starting from A and going to B, and that's how I do it. I start from A, go to B. And now suppose I add a point C, and C equals, we'll have that maybe down here at like what, 8 and 2, 8, 2. Now I'd like to go from then B to C, and I can do that the same way. I can say, well, B 1 minus t plus C, uppercase C, times t. And there I have that one. Now, though, this is not quite a path. I mean, it's a piecewise path, except you see I've got t going from 0 to 1 and then 0 to 1 again. What I really like to do is have t here go from from 1 to 2. But of course you see I overshoot it that way. Well, actually that's pretty easy to take care of. I just need this to go from it used to go from 0 to 1, and or well, actually if t was 0 it went from 1 to 0. So now notice if I make that a 2, then when t is 1 it starts as 1, and when t is 2 it goes to 0. And then here my problem is this used to go from 0 to 1. When t was 0 this was 0, whoops, and when t was 1 it was 1. I keep clicking stuff, sorry. So how do I make this go from 0 to 1 again? Well, if I just take t minus 1, well, I need to put it in parentheses. I can do that. And actually, if I just kind of follow that pattern, if I need to do another segment, you know, now I don't have a point D, I can put one in, but let me copy this. And suppose I want to go from C to D. It won't like this because it doesn't know what D is. You know, then what I would do is I would simply go from 3 there and 2 there, and you know, I just need to put in my D. Let's put in D to go to maybe 4, negative 2. So D equals 4, negative 2. And if I just follow that pattern of making this a 2 and that a 3, you see I get that, and now t goes from 0 up to 1 and then to 2 and then to 3, and I make it around all my points there. Okay, so you know, I can put together straight lines this way pretty easily if I just have the points. And of course here I've done it as the points, you know, just b times. Well, again, I could take instead of this b times, or well, let's start with a times 1 minus t and b times t. Well, I could have taken the components 1 times 1 minus t plus, and the b was 4, so 4t comma, and then 2 times 1 minus t, and the 6, so plus 6 times t. It's just a lot more to write, but notice that green segment right over this green segment. Interesting, both were green. But it, you know, if I come down here and turn off this one, you don't notice anything because this one is in the exact same spot. And so I just took the x values, the 1 and the 4, and did that same 1 minus t and t, and then the y values did that same thing. So it's just a little cleaner if I use if I name the points and do it this way, put it in that way. Okay, so hopefully that will help more with the parameterized paths. Certainly people can still ask me more questions.